we're going to try and do the 2018 paper question 1b. Okay, so there is you need to be really clear on this question that you're going to actually link some of the information that is in question 1b part 1 to the rest of the question. James takes 40 minutes to jog 5 kilometres from his home. What is the average speed that he is jogging from his home to school? You want to know the speed, so that's kilometres per minute. So if he's done 5 kilometres over 40 minutes, and that gives him 1/8 kilometres per minute, or 0.125 kilometres per minute. The next question is this one. Okay, it's important that you get a chance to read that, so I'm going to switch to another screen. I've copied that across to another screen. Okay, so my question is up here. Right, so reading this one here, Emma lives further away from school than James does. They leave their home at the same time. Emma rides her bike to school and James jogs to school. Since he jogs to school, that is the speed that you have just worked out, that he jogs to school. They meet at 20 minutes after they leave their homes. After they meet, James and Emma change their travelling speed, so they are the same. So let's try and do this. Now, you had to make a decision about what you want the left-hand axis to be. So I decided it would be distance to school. The reason I decided that is that the distance to school is actually 5 kilometres, because in the previous question they said it was 5 kilometres. So it's 5 kilometres from James. Okay, so from James, he starts here, 5 kilometres away from school. Okay. He jogs, so he's going to go at a rate of 1.25 kilometres per hour. At 20 minutes, he's going to meet up with Emma, okay, after they leave their homes, and then they'll travel at the same speed, and they're going to arrive at school 30 minutes after they left. So 30 minutes after they left, which means from 20 to 30, they're going to go in this direction, and they're going to arrive at school, and that will be the completed distance to school. They'll be at 0 distance. So we know that exists there. Okay, so you know that should be steeper than the distance that James is jogging. James is jogging from here to here, so I'm just going to give that a different colour. Whoopsies. Make that a bit fatter. Just going to draw that in there. Okay, so you know this one here has a gradient of 0.125, and it's negative because it's going downwards. Okay, so in that case there, the equation of the blue line will be this thing over here. Y equals negative 1.25x plus 5, because it goes through a y-intercept of 5. You also know that at 20 minutes here, that you can use that equation and find out how far away from school it is. So using over here, next is 20. Okay, put in 20 for x, and that will give you the distance it is at 20 minutes. So this point here is at 2.5. So this point here is the point 20, 2.5 away from school. Okay, so now that you've got that, you could write an equation for this. So what are you also told? Emma begins running, and Emma rides a bike at 3/4 of the speed. So this gradient here, if this is Emma's gradient, okay, so it will be 3/4 of the speed that she had been travelling earlier. So Emma is obviously further away from school, so it says up here, Emma is further away from school than James, so she will start further away from school. Whoopsies. So she'll start further away from school. I have no idea where that one is, and she will actually continue down. So I'm going to make her red, okay, and she will go down to here. So this gradient for this one we don't know, but you know that the gradient for this one down here will be m equals 3/4. So the gradient here will be 3/4 of whatever the gradient is up there. So we'll put that right down here, that the gradient of that is that one there. Okay. So we need to be able to find the equation for this line. We can work out the equation for this line because I know this point here. Okay, I know this point here, and I know this point here, so we must be able to work out, whoopsies, let's just change that one, 3/4 of whatever the gradient is up there, because we don't know this one. Okay, so we know that we can work out the equation of this one. You can do that by putting it into your graphics calculator. If you put it into your graphics calculator, you should get